know, math doesn't work when we're falling behind. So, many of you did pretty well on the test. I do have to finish off a couple, and I'm waiting until Thursday, Friday to share those results anyway, um, just because I have a couple people that still have to take it, and not necessarily waiting just for that, but yeah, but many did well. So take a deep breath. But the most parts that were missed were the coordinate trig, no calculator parts. And if you're using your calculator for questions that I'm telling you not to, you're your own worst enemy. So anyone that sine of 180 and you're just typing it on your calculator and writing an answer down, that will never be on a calculator part. You will have to get this trigonometry, just get the idea of drawing a coordinate and doing that. And what's starting to happen now is all the things that I told you are massively important that you need to solidify and learn are coming together now. The idea of moving an angle clockwise or counterclockwise. I actually said that in the wrong order. Positive is counterclockwise, negative is clockwise. The ability to go beyond 360 degrees and find coterminal angles, because now we're going to add to that concept a little bit today, and now we're going to start throwing trig together. Knowing SOHCAHTOA, I think some people don't actually know that from their Math 2 days, and that's why Sir Kicks or Ticks is a problem. And that's really where I'm going to start with and try to help you guys that were not here yesterday, second half of the alphabet, plus some absences. Isabella, are you sitting down yet? You're making me dizzy looking at you walk around here. SOHCAHTOA. I actually just did this today with my Math 2 students. And I know they're in honors, but the regulars do this as well. And they get this introduction. And I taught Math 2 regular about 5 years ago. Big trig component. Hopefully they haven't steered away from that with you guys. So SOHCAHTOA is, we should know what to do. I taught that in the Wednesday that we first got back from break. And then it turned into Sir Kicks or Ticks. Because in many questions, you don't have the option. You don't have a triangle with those quadrantals. So you must know the transformation into that. And all it means is when you draw your triangle appropriately, the opposite side will always be the y coordinate. This is coordinate trig. This isn't, I know we keep going back and forth between coordinate trig and not. But today, as anyone that watched the Ed puzzle, that was not coordinate trig. That was 100% SOHCAHTOA. And then now we should be able to get better with that. I will share what we did yesterday just as a recap so I can have some sort of connection to moving on. And that's the idea of special triangles. And this should be 100% review, but do take a breath. Yes, second half of the alphabet people that we're going to break this down tomorrow a little further. We're going to derive. And you shouldn't be sad about deriving. I think deriving actually solidifies if you listen, memorizing in the brain and knowing where things come from. I think it's important. So yesterday we did reiterate Sir Kicks or Ticks and the brothers, the reciprocal brothers or sisters. So we know a 45, 45, 90. Oops, sorry, put that in the wrong spot. Is an isosceles triangle. So what I said is, and we derive this, we'll do this in the notes tomorrow, no matter what I pick for this side, hey, let's pick this as length A, and that's a length. It's just a variable. Then this side would have to be length A. And then we derived this yesterday through the Pythagorean theorem that no matter what these two side lengths here, this hypotenuse is always whatever that side length is times the square root of 2. And that's it. And you just have to have this memorized and locked in and understand that. And I did 2 examples where A was 1, and then I changed it to 7, I think in class specifically. And when it was 1, I ended up with the Pythagorean theorem, 1, 1, 1 root 2. When it was 7, the sides were 7, 7, and 7 root 2. So through that extrapolation, it must be true for all 45, 45, 90s. And it is. For a 30, 60, 90, I did go through this with you, breaking down what the book does, which I love, love, love this book. And I did 2 examples of what happens with a 30, 60, 90. You start with a 30-degree side, and you call that, and that is the smallest side. Let's just call that A. So pick whatever letter you want for that. I couldn't care less. The 60-degree side, then, and it's when I say 60-degree side, the side opposite 60 degrees. So knowing how to move in a triangle and knowing what opposite side means is whatever A is times the square root of 3. And then the 90-degree side is whatever A is times 2. So having these memorized and understanding that and locking those in is our next crucial component. So if I can kind of think of all the things that we need to know at this point, how to move in a coordinate plane with an angle measure, positive and negative, knowing that we're doing coordinate trig, and we draw our triangle like a coordinate. And now we're going to move on to knowing what a 30, 60, 90 and a 45, 45, 90 relationship is, and then putting it all together. All right. And that's where we're at right now. Okay. So I'm going to move on. The very first concept, get the chat ready. Oh, and I hope you're just like my fifth hour. I'm not kidding. They were awesome with the chat about the idea of what a reference angle is. Now I'm just going to show you my drawings here. Not mine, sorry, the book. Again, loving the book. Love it, love it, love it, love it, love it. I got 4 drawings here. Yeah, because I want to note all 4 quadrants. And I'm going to block this out because this is the person that writes this down is a formula robot. They don't allow their mind to think. They just want on a written piece of paper, how do I find that number? All right. And it should be easier than that. So here are 4 possible triangles. I only drew 2 of them. I'm going to move in on this. I'm actually going to focus on quadrant 2, kind of like what I did with some other notes right there. That's what I mean about old news here. I have some people that did not and do not draw a triangle when we have a coordinate. So remember, this is the coordinate. It's right here. And our terminal sides in our triangles in a coordinate plane flow through that. And that's the ending side of this triangle here. What we're going to, and I'll show you my paragraph off to the side that you can write as a note taker, in the time that we have allowed here, what a reference angle is by definition. But before I do that, when I have this angle measure here, well, what I had to do is when it goes through this coordinate is draw my triangle X first, then Y, and then back down to the origin R. And again, I cannot help you if you don't know how to draw coordinates, meaning X is always first, Y is second, then you snap R back to the origin. R just stands for radius. I know that comes out of nowhere because we haven't seen a circle yet. If you draw your triangle ever like this on the chapter 2 test, I will guarantee you that you get 0 credit because this is 100% long. I lost my pen. You know how that happens. If you draw Y first, then X, and then do this, I have no sympathy for you. I can't do anything for you because you're not listening to me right now. All right. You draw coordinates X first, then Y, then, when you're drawing coordinates in grade school, why would we start drawing coordinates Y first, then X second? I just don't know what to tell you. But I will say this, that you will get no credit. All right. That you're actually going to get all your answers wrong. So I can't be more adamant about how important that is. But every year, we got, that thing happening. So I don't even know where to proceed on that. Okay, get ready. Get ready. I'm going to tell you right now that this is what's called a reference angle. This is actually the most important angle that we have to deal with this. In the chat, wait for the 5-second countdown. I'm going to say that theta is actually, let's pick one that's kind of easy, is 130 degrees. In 5 seconds, what's the reference angle? 4, 3, 2, 1, 0. What is that reference angle right there? Boom, I was hoping for quicker. 2, 2, 2. We got 3 people only. Oh, my last fifth hour, it was like I got 12 people. I was like, oh my gosh, I'm so excited. People are actually paying attention and doing and writing. Amazing. Yeah, you're right. It's actually easy. That's why I blocked this off. I'm not gonna have like, what formula do I have to use in order to get that reference angle? It's simple. We know a half turn is 180. So if I had a 130 degree actual angle measure, then this angle measures 50 degrees. That's really the first part of our homework today. Although I'm not going to give you any homework until Thursday, Friday on this stuff. So that was just like an actuality of how we make a reference triangle. and draw it. Let's go to quadrant 3. So again, I get an angle measure. Let's play the game again. Ooh, let's make it tough. Let's say let's say theta is equal to. I hope you at least know it's got to be between 270 and wrong. It's got to be between 180 and 270. Let's say 213. In 5 seconds, what's the reference angle? 5, 4, 3, 2, 1, 0. Wah, wah, wah. 6 hours killing me, Smalls. Nobody cares. I'm putting this on the video. Hey, video, YouTube. 5th hour, I had about 15 people put the answer what the reference angle is. Sadly, nobody in 6 hour wants to do that. All right, I guess I'll move on. Poor Mr. Samuelus. 180 degrees. Anyone want to just say, be somewhat positive and write what they think the referencing? Nice. Okay, is Alexander, that's why you were nervous about writing the answer down? Thanks, Alexander. I should give you extra credit. 33. It's not a magical situation there. We should know that I did 180 at least, a half circle, and then what's left over to complete the 213. Now, why is that called a reference angle? Because your triangle still, this is dealing with coordinate trig. So I will have an X, I will have a Y. So it's this coordinate that the terminal side is passing through. So it's this enclosed angle measure that's connected to the origin, which is what a reference angle is. All right, thanks, Alexander. The only one. All right, and then we could end up in quadrant 1 very easily, or quadrant 4. I think I did play a game with 5th hour about a quadrant 4 angle measure. I think I said 300 degrees. Hey, what would the reference angle be if it was 300 degrees? And then those from yesterday will understand how this is going to be special coming up here. 5, 4, 3. Oh, okay, Alexander, sorry. I started the clock too late. But yet again, you're by yourself, Alexander. So I'm not sure what's happening out there. Because this is, thanks, Aiden, 300 plus another 60. So this enclosed angle measure would end up being 60 degrees right there. Just knowing that a full turn is 360 gets me that reference angle pretty easily. Okay, so here's a bridge into all the things, putting all the things together and how we find trig in a coordinate plane with special angle measures. We will use the reference angles to create reference triangles. And you do that by coordinate move, x first, y second, then come back to the origin. So we've already established that the x coordinate is the adjacent side. The opposite side is always the y coordinate. The hypotenuse shall now be called r for radius, which you don't really know about that yet because we haven't done a unit circle. And we won't. It's not really that important. I don't put too much stuff on the unit circle because it's really about knowing, what we're doing here is really the key. You know what a unit circle is anyway, so it doesn't matter. Talk about something that doesn't mean anything to you. I don't know if I took attendance yet. Going to go ahead and do that right now as we get people going here. Oops, hit the wrong thing. Oh boy, I'm struggling. Giving the note takers an extra chance to take some stuff down. Copy. Ooh, showing students' faces on the video. Okay, all right. I think that should be good enough. Okay, let's go to the chat. Hopefully we have, this is why I love the book as well. And, we'll probably have these, hopefully you had enough time to write all those and you just get the concept. I don't think you need all 4 pictures. But if you have your book, I just cut right out of the book, that little section there. But there we go again. A common error is to find a reference angle by using a terminal side of theta and the y-axis. That's the disaster. That's the student that does not understand that it's because of coordinate moves. Coordinate moves. It's always, when you're drawing your triangle, x first, then y, then r. R comes back to the origin. And that reference angle is connected to that origin, all right? And that's what the reference angle is. Okay, the first one, I'm going to make this, the second one, a little bit more of a challenge. But that's what your homework starts off with, that you'll look at Thursday and or Friday. Maybe today I'll put it in the calendar, but there's not much you could probably do with it. You could do a couple things, but find reference angles and stuff. In the chat in 5 seconds. Don't go too early, Alexander. You might be the only one. Well, I feel like Aiden's involved as well. What's the reference angle for 218? 5, 4, 3, 2, 1, 0. All right, we got a few more. Yay! And a couple wrong answers, but that's okay. Don't be afraid. A lot of 52s. That's interesting. You went off of the y-axis. Nice. Okay, so don't ever do that again, because here's the move. It's always based off of the x-axis, not the y. So in answering it wrong, you get the learning by mistake idea, and that's actually a good thing. That's why we're not afraid to try. All right, so it's actually 180, and then what's left over to still be based off of the x-axis. So those that said 52, you're doing that bad triangle off of the y-axis. So don't, make sure you don't do that anymore. So it's 32 more. And that's why the answer, or 38 more. Sorry, I had that 2 in my mind. Because the triangle must be x, then y, then back to the origin. So that's why it's this 38 degrees, not the 52. Okay? So I'm glad to see that. It's actually not a bad thing to get that wrong off the bat. Just make sure in the future you never do that again. And that's what learning is. So the reference angle is actually 38 degrees. And by the way, reference angles are always listed as a positive. Right? So just make sure you understand that so we can use it. Okay. This one's going to be a little bit tough. I already know the answer because the last hour I had to get my calculator out. Let's see if anyone can get that one. And no time limit. Let's see if somebody can get this one pretty quick. I'm going to see if you can. Now I'll show you what happens with this and what you should do, but I want to see if someone can beat me. Alexander is like the MVP of the day, man. Here's what Alexander probably did. Alexander, do you agree? Did you just start adding 360? Shake your head, yes or no. So there's one that, by the way, remember, this is clockwise. So that's one of the key components. I slapped a negative on this, so you go clockwise. There's one negative 360. There's another negative 360. There's another negative 360. So this equals negative 360. Not that you don't have to write this as like a note thing. Oh, I'm losing people. Okay. But I did that 3 times, and this would be on a calculator part. And I do feel bad for the second, I forget what half of the class. On the no calculator part, I put an obnoxious Pythagorean theorem question. Which half was that? First half or second half of the alphabet? You guys don't remember? Did someone have an obnoxious Pythagorean theorem when we had to do the no calculator part? All right, I'm getting nothing out of 6 hour. No responses. Okay. But then, Alexander, weren't you left with negative 307? Right? Was that correct? When you added 360 3 times? Anyone else agree with me? Can someone shake their head? Yeah. So then what's negative 307? Well, that lands, maybe you added 360 one more time, and then that actually exposed the reference angle. So maybe Alex did it 4 times. So that means 53 degrees is the angle measure attached to the x-axis, because x, comma, y, comma, r is the rule of drawing that triangle. So the answer is right, Alexander, however you found it. Maybe adding 364 times gets you to that, but that tells you exactly where that terminal side is. So again, that's chapter 1, knowing where the terminal side lands. Okay, good. There it is. Alexander put it in the chat. Okay, good. I think I spent a lot of time on that one because I had to grab my calculator out in 5th hour because I wasn't sure what was going on there. Now, I know this is going to be sad for those that were not here, but try to remember what I'm doing now, and then what this will bridge into Thursday, Friday. But if you get this, if you remember this, then the next thing I'm going to do is not really a big deal. If you remember that sides have these relationships in 45, 45, 90s and 30, 60, 90s, this last example will not be a big deal. And I'm only going to do one. Because I know this is going to be our big day on Thursday, Friday, right? Because I still have to teach the Tuesday people tomorrow, so on and so forth. So, okay, so I don't have an example there yet. I wasn't sure where we would be at this point, but I know what kind of questions I want to ask. So find the exact values of the 6 trig functions for each angle. This is like starting with, I don't know what number in the homework. Rationalize denominators when applicable. Some of you got nailed on that. I literally said that in the definition or the directions on the quiz for chapter 1. We didn't do that, so 1 point off. Sorry. Okay, so here's the angle measure in question. 225. Alexander, you don't get the answer. Aiden, you don't get the answer. You've done awesome today. Everyone or anyone else in the chat, what is the reference angle? As I write, here's what we're actually finding. We're finding the 6 trig functions of 225. Anyone put it there yet? Alexander and Aiden are like, come on, I want to do it. Do we have anyone on there yet? Nice. Michael Collin, that was about close to a tie. Natalie, very close. Skylar, it was so close that I know you were hitting enter as the other ones were in there. So I give you all credit on that one. Nicely done. It is 45. And then this will tell you where this is going. By the way, here's people that struggle with trig. They don't remember that cosecant's related to sine reciprocally. They don't remember that cosine's related to secants reciprocally. And then cotangent, that's usually pretty easy. This is what we're ultimately finding, but we're not using our calculator. We're actually putting it in exact form. That means, again, no calculator, because if you use your calculator, you just get decimals, which are approximations. But here's how you draw this now. This is where your world's going. This is putting 1 and 2 all together, all this coordinate trig idea, and moving along from there. It is 45. Oh, I should have asked what quadrant we're in as well, but too late. We're running out of time. This is a 180-degree move. Huh. Okay. And I know I have to go positively, so I have to go counterclockwise. So that's how the people got 45 so quick. Now, 45s are tricky. You know, it's not 45 based off of the y-axis. It's 45 based off of the x-axis. Because my coordinate plane should be x, comma, y, then r, every single triangle. So knowing that this is a 45, 45, 90, now I can put yesterday's stuff in play. Watch what I do. Okay, well, Mr. Samuelis told me all 45, 45, 90s are a root 2 for side measures. But I'm going to pick a number for a. The easiest number in the world is 1. So I'm going to say this side is 1, this side is 1, and this side is 1 root 2, which I don't need the 1 in front of that. And that's the side measures you're going to be dealing with a billion times with 45, 45, 90s. But I'm still wrong. This is coordinate trig. This is a coordinate that I moved left and down, so these two are negative. Or have that piggyback thing, all students take calculus. Take means tangent and cotangent are positive. The rest are negative. And that will happen naturally when I start putting these signs together. So this is just an extra help for all students take calculus. What are the signs when I'm dealing with coordinate trig? And that's what I mean about putting all these things together in one nice little complete little lesson here. Okay, then I guess one more thing. This is the reference angle. So you are actually allowed to think about opposite, adjacent, and hypotenuse if you don't like cirkicks or ticks. And you can play SOHCAHTOA, but I am going to put up there, opposite is always Y, adjacent is always X, hypotenuse we shall call R from now on. And now we play cirkicks or ticks or SOHCAHTOA. I couldn't care less which one you do. Sine is opposite over hypotenuse, -1 over root 2. Those that were with me yesterday rationalizing, that's -root 2 over 2. Cosine is the same. And this is what I was able to ask people in class. Everyone had to answer a question yesterday in class. Tangent is -1 over 1. So that's how that became positive. If you truly put those as coordinates, -1 over -1 is +1. You don't have to write the positive, but it might be nice to write these things just to solidify. Don't flip the circled, flip -1 over √2. Okay, we'll call it a day, and we'll piggyback off this and do more of these reference angles. Boy, some people who left fast. Benjamin, man, he left like a ninja. I'm out of here. All right. We'll see you guys.